Flynn Nation. What's up, you pussy-ass pussies? Let's just get right into the podcast. Enough being quirky. Enough going like this. Let's just do it. Let's do a podcast. Okay. I'm not gonna lie to you guys, I'm kind of pissed off. Got some shit that I bought that hasn't fucking arrived. They're really fucking with me. Definitely not gonna use those fucks as suppliers, huh? Man, I just want my shit to arrive so that I can create a TikTok page for it and I can start drop shipping it. That would be fucking amazing. Man, that would be fucking awesome. But they're fucking with me, man. They're fucking with me. So, that isn't good news. Give me my shit, bitch. What the fuck? How many of these sold? None. Fuck's sakes, I don't give a fuck if you sold none. You've sold none. You have a 0% positive feedback. Why am I... You don't even have 10 ratings. The fuck were you expecting? That picture's actually pretty good. I might just real quick steal your shit. Steal your motherfucking pictures. Wait, what's this picture? That's different. That's not even the same one. This is a different product altogether. The fuck is going on? Anyways, fuck's sakes. I'm pissed. Let's start doing some shit. Let's just start. All I have to do is skim over fucking still surveying SQ3R. Got tomorrow off and I'm doing legs at the gym today, so I can get some more sleep. I want sleep for my body. Hey, let's see what my credits are made up of. 6 excellence, 3 merit. That's a dub. Let's go. I'm the fucking man. Anyone who thinks that they're the man is wrong, because I'm the fucking man. Except I'm not the fucking man. And I'm able to realize it. My ego's up here, but I'm still able to realize that my ego, I'm a bit delusional, I ain't the best yet. I ain't the best yet, and it's good that I know that. For most people, it's the other way around, and it was, for me, the other way around, where most people don't think, oh yeah, I'm the best, and then it turns out that they ain't the best. It's the other way around. They think that they're dog shit, and, they're not as dog shit, but they're not fulfilling their potential because they think that they're dog shit, so. Tips? Let's have a look at some tips. No, I don't need tips. Fuck you. Fuck you, Danae. Deline. With your fucking shitty cat chemistry memes. Fuck's sake, stop showing me memes. Deline, stop showing me cat memes. Of chemistry. If organic chemistry was easy, it would be called biology. What the fuck, Deline? Get out of here. Alright, let's fucking begin the lesson. Deline, if you're watching this, fuck you! Yeah, you thought I was gonna say sorry? Anyways, enough being quirky. I've got a lot of pimples on my face. I'm a pimply fuck. I can't grow a mustache or a beard. I've got a freckle there. But let's just get right on into it. Biofactual group. Oh shit, Okay, specialised glassware. What the fuck are you talking about? Carrying out an organic reaction usually requires... You see this? Get the fuck out of my way, cunt. You're fucking hitting my elbow. Due to the weak intermolecular... Carrying out an organic reaction usually requires specialised pieces of glassware. I don't give a fuck. 5 types of reactions: addition, elimination, oxidation, reduction, substitution. The reactive side. The reactive site is the functional group. Dude, I am tired. It's when I'm doing the schoolwork that I start getting tired. I'm not actually tired, but my head is feeling warm. It's the feeling before being tired. This is doing shit. Oh god. Fucking boring. Look at those teeth there. Oh, there they are. Perfect teeth. What the fuck's a reactor? Is the functional group or the carbon atom bonded to the functional group? Yada 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 yada. Leaving groups. What the fuck? You gotta stop swearing as much, eh? This type applies mainly to substitution reactions because an atom or group of atoms has to leave when it is replaced with an incoming atom or group of atoms. So what part of the molecule will leave? Drake. Swalala. Today is the 14th of September 2021. It's a Tuesday. Swalala. And on the date, 18th of November 2052, it is going to be a Thursday. I saw this video once where it's like this autistic kid. I don't know if he was autistic. I think he was autistic. He could like tell any day that it was going to be in the future. I don't know how he could do it, but he could tell like any fucking day, like 2054, November 3rd, what day is it going to be? And he could tell like that what day it was going to be. And I just did it just then, because if you have a look on whatever fucking date I just said, I got the day right, didn't I? Yeah, that's right. I'm the fucking man. Key points. Okay, let's just have a look at key points. Oh shit. Organic reactions tend to be slow as more energy is required to break the strong covalent bonds. Organic reactions are usually heated to speed up the rate of reaction. What is organic chemistry again? What is an organic reaction? Oh shit. This is the part where I question the fundamentals. And I realize, oh shit, I didn't know the fundamentals. Organic reactions are usually heated to speed up the rate of reaction. Water baths are often used as many organic compounds are inflammable, burn easily. Let's have a look at this dude's rule. What the fuck's wrong with the name? Mark Comnicove's rule. Okay, that's just the rich get richer, poor get poorer. Used to predict the major and minor products of elimination and addition reactions. I forgot about major and minor products. How many lessons are there? No. I'm already tired. Okay, fuck. There's 11 lessons. I have to get through 10. This isn't hard work. I'm just tired, man. Alright, I'll be back. I'm gonna fill this up, see my family. Hopefully, my energy levels will boost. Shimmy, 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 get more sleep. I definitely need to get more sleep. Okay. That's fucking hilarious. Alright, let's get back to work, eh? I like a bit like this. Alright. Let's skim SQ3R, skim survey. Let's survey. Won't you see without my light? Remember the tips given in the previous lesson? Let's examine the blah 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 blah. Hey, you a bitch. Characteristic reaction of alkenes addition across the double bond. For example of addition reactions are what? During hydration and hydrohalogenation, different atoms or groups of atoms add across the double bond. During hydrohalogenation, a hydrogen atom adds to the one carbon atom of the double bond, while a halogen adds to the second carbon atom. That's... Okay, let's watch this video.
Hydrogen halides.
Holy shit, that is good quality. Even better quality than this podcast right here.
That is hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide easily add to the double carbon-carbon bond because their molecules are highly polarized. An example of an electrophile that adds to alkynes is hydrogen chloride. Owing to the electronegativity difference between hydrogen and chlorine, the hydrogen atom in a hydrogen chloride molecule is positively charged, and the chlorine atom has a negative charge. In the first step of the addition reaction, a hydrogen chloride molecule approaches an ethene molecule, orienting its positive pole towards the electron-rich double bond.
Yep.
Now the pi bond breaks.
What the fuck's a pi bond? No, that's actually something that rings a bell, so. Look out for pi bond. I don't know what the fuck a pi bond is. Is that just a double bond? Is that what you're saying? Fucking pi bond? What's next? A pizza bond? Sorry. Alright, let's fucking play. I don't want to see more videos.
The electron pair that formed this bond attaches itself to the positively charged end of the hydrogen chloride molecule.
No, that's negative. That's just positive,
As a
homie.
result of this
That's just
change,
positive.
a chloride anion forms, together with a positively charged chemical entity known
What's
as
an anion? I can't remember. Anion. Cation. No, cathode and anode.
carbocation.
Cation. Yeah, it actually is. Cation. That's just positive. How the fuck did I not connect the dots there?
Next step, the chloride anion attacks the reactive
Are you saying
carbocation
attacks? What the fuck's going on?
to give chloroethane.
Chloroethane.
The addition reaction is completed. The reaction between hydrogen halides and alkenes is referred to as electrophilic addition, AE.
Ay. Okay, cool. Good video. Reaction conditions. Consider you speed up the addition of water across the room. Okay. Okay, this video explains it apparently.
The addition of
Fuck you, I'm not watching this shit cunt quality video again. Major and minor products, right, I remember those. So far you've examined the reactive side and looked at the types of reaction that alkene will undergo. Now consider the 7th point listed in lesson 1. Why can a mixture of products form and why the products form in differing amounts? Blah 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 blah. Blah 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 blah. Only one product is possible. Namely, what do you mean namely? Just only one product is possible. Chloroethane. When HCl adds to propene or any unsymmetrical alkene, two products are available as shown below. The first reaction, the hydrogen atoms from HCl adds on to the carbon that adds two hydrogens. I'm not even reading that. More in depth, blah 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 blah. Okay, please be fucking better than dog shit quality. Just don't be dog shit quality.
let us follow
For the love of fuck. Alright, let's just watch this video, I suppose.
Markovnikov's rule for the addition of hydrogen bromide to
What the
propene.
fuck is going on?
We will try to explain the rule in terms of carbocation stability. Unlike an ethene molecule, a propene molecule is unsymmetrical. So we can expect more than one addition product in this case. Therefore, we have to consider two possible reaction paths. The first path will proceed via a symmetrical carbocation, with the positive charge around the central carbon atom. The second option is the formation of an unsymmetrical carbocation, in which the positive charge is situated on one of the further carbon atoms.
Right.
If we compare both transitional carbocations, we can see that the first one is a more stable secondary carbocation.
Carbocation. I thought it said carbocation. I thought that was how you pronounce it.
Whereas the second carbocation is a primary one, and therefore less stable. The reaction favours the formation of the more stable secondary carbocation,
Yep.
which is why the main reaction product is 2-bromopropane, whereas 1-bromopropane forms in only small quantities. Note that in the case of 2-bromopropane, the hydrogen atom adds to the carbon atom, bearing the greater number of hydrogen atoms. Thus, the reason why alkenes undergo addition in according to Markovnikov's rule
Let's get richer.
is the difference in the stability of carbocations.
Alright, don't worry. I don't even know what my Markovnikov's rule is. What's the rule that the rich get richer and the poor get poor? I know that one. I know that's right. What the fuck's a chest? Oh, my old man is skateboarding with a basketball in his hand. He went skateboarding at the school. Really just want to get a chiropractor and just snap. There you go. Snap. Not snap, crack, Jesus Christ. Crack. Nucleophiles. The more electronegative halogen attracts the bonding electrons more strongly, leaving the halocarbon electron poor. Well, how does that make any sense? Dude, I'm seriously about to fall asleep here. This ain't it. I'm gonna watch some videos. I'm just gonna finish this one and then just watch some videos and then fucking make some TikToks and shit. Cause this shit is so boring. It's not even that boring, I'm just kind of... If it was exciting, I wouldn't be falling asleep. But I am kind of tired. I don't know. This is 8 steps rule. Just in, man, just in. Dude, how the fuck are you not over, cunt? There's a mess to listen. Alright, okay, good, let's watch some videos. Let's see this dude's face, has he done... Choke me if you hate me, but you love me. Has he revealed his face? See what this kid looks like. Guess not. Looked like they did an interview with him though. But he's like, is that what he looks like though? What the fuck? No, it's fucking... Okay, fuck mate. What the fuck am I doing? Right, sorry. I'm typing organic chemistry into Google. There. Choke me if you hate me, but you love me. Low key, you wanna date me when you fuck me. Fucking will watch this video. Hey, I did redox chemistry, I got excellent. Easy ones. Concepts. Choke me if you hate me, but you love me. Low key, you wanna date me when you fuck me.
Welcome to this video on polymerization. Now, polymerization is when you take single molecules and we call
30
these
minutes.
monomers. You join them all together.
But it's 5 o'clock. Alright. I spent like 10 minutes just like fucking filling up a water bottle.
To get one long chain, which is called a polymer. And
Yeah, I gotta stand. If I lay on my bed, I'm fucking gonna zone the fuck out. Oh, I need my fucking package to arrive. Deliver my package, you fucks.
Polymerization is the process of how that happens. Now, we did learn some stuff about this in level 2, and this was all to do with addition reactions. So we'd have a group of alkenes with double bonds in them, and that's what we knew polymerization was. Now, those double bonds would break open, and one open bond from one molecule would connect to another open bond from another molecule. And all together, they'd be pulled up and make one long chain called a polymer.
Rewind.
Welcome to this video on polymerization. Now, polymerization is...
Let's store these curtains as well. I'm not stalling. Maybe I do stall. If you notice that in my behaviour, that I stall, that I don't just go into focus zone. Maybe I just need to go into focus zone and really slot out in a lot of time where I study. But I'm new to this studying method. It doesn't really even seem like studying, skimming. But I suppose it is, isn't it? Plus, really, you're supposed to do all three of them on the same day, aren't you? You're supposed to start off with yesterday's topic that you skimmed over, go over the lecture or the notes, or not the notes, go over the lecture or the class or whatever that you're doing. Apply the Feynman technique afterwards. Recall as soon as you can, directly after class. Think about exactly what you learnt. Try and recall that. Make flashcards based on that recollection. That recollection, is that a word? Why do I keep on fucking voice cracking? Let's say fucking word. Fuck! Basically recall your shit. Make some fucking flashcards about it. Practice your flashcards. Do practice questions on it. And then skim through next day's topic, can't you? It's a lot of shit to do. Yeah, that is a lot of shit to do. You do the class. You make some flashcards, recall it, whatever. apply Feynman technique. So basically, you just go to class, do your flashcards, do practice questions, skim.
Is when you take single molecules, and we call these monomers, and you join them all together to get one
I'm not
long...
listening, you fuck.
Welcome to this video on polymerization. Now, polymerization is when you take single molecules, and we call these monomers, and you join them all together to get one long chain, which is called a polymer.
Yep.
And polymerization is the process of how that happens.
I remember now.
Now, we did learn some stuff about this in level 2, and this was all to do with addition reactions. So we'd have a group of alkenes with double bonds in them, and that's what we knew polymerization was. Now, those double bonds would break open, and one open bond from one molecule would connect to another open bond from another molecule. And all together, they'd be pulled up and make one long chain called a polymer. So the terms we needed to learn were a monomer, which are these individual parts, and polymer, which is the long chain once they've added all together. So if you want more detail on this, go to the level 2 organic chemistry video on addition reactions. There's more in there. Now, the one we're going to focus on today is condensation polymerization. And it's called this because they all undergo condensation reactions. Now, we saw a few condensation reactions in video 2 in reaction schemes. Now, two of the most notable were when a carboxylic acid and an alcohol create an ester. Now, that has a byproduct of water. And the same thing with an acyl chloride and alcohol create an ester, and they have a byproduct of HCl, hydrochloric acid. Now, a condensation reaction is when two small particles, one from each of the reactants, joins together to make another molecule. In this first one, we get a hydrogen from alcohol and an OH group from the carboxylic acid, and that joins together to make H2O, or water. In the second one, we have a chlorine group plus an H from alcohol to join together and make HCl. Because they join together, it's called condensing, and therefore these are condensation reactions. Now, this is relevant because in this video, there's going to be condensation reactions where we remove small particles, and in turn, bigger particles or molecules join together to make polymers. Now, there's two different ways that you can make polymers with condensation polymerization. Now, the first one is when you have one type of monomer with two different functional groups. And you need two different functional groups, kind of like if you're linking arms with somebody to create a long person-to-person chain. You need to link arms on both sides, so you have two arms, or in the case of a monomer, two functional groups, both of which could link to the next molecule. So we could have one molecule with two different functional groups, or we could have two different molecules with each of their functional groups twice. So they'd join together, and then they'd have two other functional groups on the outside to create one long polymer. So let's look into detail about how some of these work, and we're going to cover 5 different reactions relating to polymerization today. So let's start by looking at two different molecules that have their functional group twice. Now, the first example is forming a polyester. Now, polyester is a really common fabric. A lot of things are made out of it. Now, this is designed by having a carboxylic acid, and it has two carboxylic acid groups on it, so we call it a dicarboxylic acid, and a diol. Now, this is an alcohol with two alcohol groups on it. And what you get is the OH from the carboxylic acid group and the H from the diol, from the alcohol part, join together to make H2O. They make water. And this leftover oxygen from the alcohol group will join straight up to the carbon from the carboxylic acid group. And this happens again as this water molecule is released, and again as this water molecule condenses together. And what you end up with is you have one long chain where these two original monomers alternate together. So they're all connected by that ester-like bond where that original oxygen holds the two molecules together. And you'll notice there's plus 3 H2Os on the end, and that's because you've condensed out the water. There's a condensation reaction. So this is a dicarboxylic acid, a two-ended carboxylic acid, plus a diol, a double-ended alcohol, and that goes to polyester, which means many esters. So you're getting lots of ester bonds again to make one long chain, plus that water which is condensed out. Now we could also do this with an acyl chloride, which has two ends, called a diacyl chloride, and a diol, again, that alcohol that has two ends on it as well. You'd get the same kind of thing. You'd still get polyester, but instead of an OH and an H being condensed out to make water, you'd have an H and a Cl condensed out to make HCl. So this is how this works when you're creating polyester, which is a common fabric. Another example we can look at is polyamides. Now again, this creates useful plastic-like things like nylon. So here we've got two groups. Here we've got an amine group and we've got a carboxylic acid group. So we could remove an H from the amine group and an OH from the carboxylic acid group. Now it could be either H from this amine group here. And directly this carbon would connect up to the nitrogen here. And the same thing would happen when we have OH and H all condensed out to make water. And that gives you a final result with an amide link in it. And you'll see the nitrogen on one skips right over this H and OH group, which has been condensed out so it makes water, and connects right up to this carbon here. And you can call this type of bond an amide link. Here we have a diamine, because we've got a two-sided amine, plus your dicarboxylic acid, your two-sided carboxylic acid, going to a polyamide. And that's a thing like nylon. So we could also do this, instead of having a double-sided carboxylic acid, we could have... Welcome to this video on reactions.
This guy seems a lot better.
Schemes. Now on level 3 organic chemistry, you learn so many different reactions. Reaction schemes is a way to bring together all of the reactions you've learned in organic, both from level 2 and from level 3, into one type of question. So in this video, there's actually no new information, but it brings together all of the previous information you might have come across. So let's quickly recap the reactions from level 2, the important ones we need to know. The first is addition reactions. And these happen from level 2 when we broke a double bond, and this is a fast reaction. So it started with an alkene, something with a double bond. And the key ones we learned were hydration, where you add an H2O, so this is where you break open the bond, one of the OHs adds on, one of the H's adds on, so you create an alcohol. Then you learn hydrogenation, where you add hydrogen on. So this turns an alkene with a double bond into an alkane, something that would have all H's around there. Then we learned about halogenation, where you break open this double bond and add on a halogen, almost always Br or Cl. And finally, we learned about Markovnikov's rule. And this is where the rich get richer. So the important thing is there'll be a major and a minor product produced. For example, when we add on a halogen. Now, you're trying to decide which carbon the H will attach to. It's the one that already has the most H's. So if you're unsure on any of this, go back and watch the level 2 videos on addition reactions. Now, also we learned about elimination reactions. Now, this is going back from an alkane towards an alkene. So specifically, we needed a reagent to make this happen, which was H2SO4 or sulfuric acid. And the examples were often an alcohol, something with an OH going back to an alkene, and that would have water produced, H2O, because you'd get the OH and the H joining together when you created this double bond. And you could get haloalkanes going back to alkenes. So instead of an OH, this might be a Cl or a Br. Now that would get kicked off along with another hydrogen, and that would create HBr or HCl. So these are the important reactions you need from level 2. And from level 3, we learned some oxidation reduction reactions. The important ones were a primary alcohol going through to an aldehyde, then a carboxylic acid, and we used the oxidizing agents of acidified permanganate and acidified dichromate to make that happen. In the same way, they would oxidize a secondary alcohol. That would go through to a ketone, but then couldn't be oxidized anymore. When we learned about reduction, we learned that aldehydes could be reduced back to a primary alcohol, and we'd do this using sodium bromohydrate, or NaBH4. Now, this sodium bromohydrate would also reduce a ketone back to a secondary alcohol as well. And remember, if you're ever using these oxidizing agents, you're going to see a color change.
Yep.
Finally, in the second video, we learned about a whole bunch of reactions between acyl chlorides, esters, amides, and carboxylic acids. So you've got a list here of an acyl chloride, which will go through to carboxylic acid or an ester, a primary amide or a secondary amide, and what you need to react this acyl chloride with. So you need to be familiar with all of these reactions because they could all come together in these exams. So now we're going to go through a typical question you might encounter in your exam. So this is something like propene can be reacted with water in the presence of acid to form a major product called A and a minor product called B. And then you're going to see a list of instructions and this big reaction scheme diagram. So you're starting with propene, which can be reacted with water in the presence of acid to produce a major product here, product A, and a minor product, product B. So this is going to be Markovnikov's rule. Then you'll go on with more instructions. So B is oxidized to form D, A is oxidized to form C, D reacts with SOCl2 to make E, E then reacts to create product F, D can react with G when you have alcohol and concentrated sulfuric acid, or it could make ester H when you mix it with alcohol A rather than alcohol B. So all of these steps are laid out and shown in this diagram, and your job is going to be to identify the reagents that happen if they're not listed and what all of these products A, B, C, D, E, F, G, and H are, as well as drawing the structural formula of these compounds. So you really need to understand all of the reactions to pull them together in a question like this. So we're going to go through this question so you can see how this would take place.
It's been 4 minutes. How's this lasting so long?
First of all, the important thing is you start with propene. So propene has 3 carbons and it has a double bond on there. Now, the important thing is it goes to a major product, which is A, and a minor product. Now, this is Markovnikov's rule where the rich get richer. And what it means is that when you add on a hydrogen, when you break open this double bond, the hydrogen is going to add on to the carbon, which already has the most hydrogens attached because it's the richest. So here you'll notice that the carbon on the left has 2 hydrogens attached. The carbon on the right only has 1 hydrogen attached. Therefore, the major product is when hydrogen attaches to this first carbon here. So this is an addition reaction where it opens up the double bond and that first carbon will get one H attached. Sometimes you bond where the carbon on the outside would get the OH group.
Oh, what the fuck? Damn it. Totally missed a lot of important shit.
This first carbon here. So this is an addition reaction where it opens up the double bond and that first carbon will get an extra hydrogen attached, so it becomes CH3 rather than CH2. The OH group from water will then get added onto this middle carbon here, so it'll be COH. It will still have one H attached to it because it's got this extra bond open to it. And then we still have this CH3 out on the right-hand side here. So that's the major product where the rich get richer. Now, that doesn't always happen. Sometimes you get the minor product as well, where the hydrogen actually attaches to the carbon with the least number of hydrogens. It doesn't happen as often, but it does still happen. So that would mean you'd break open this double bond where the carbon on the outside would get the OH group attached. Now, it doesn't happen often, but it does happen. So here we've got the carbon on the outside with the OH group attached. We've flipped it around. And you'll notice that this has 2 H's, so CH2 and the OH attached to it. And this middle carbon is CH2 as well. It's got its original hydrogen plus another hydrogen that's been added on from this open bond. And then there's still CH3, which comes off from down here. So this is an addition reaction where you need to follow Markovnikov's rule to get your major and minor products.
Obvious.
Now that we've done that, we can look at what happens to both A and B. You notice that product A, which we've named as propan-2-ol, because it's propanol and the OH group is on 2, versus propan-1-ol, where the OH group is on carbon number 1. So they can undergo oxidation. If you want to oxidize here a secondary alcohol, you're going to get a different product to if you try to oxidize a primary alcohol. So let's look at the oxidation reduction reactions we already know. So here we've got a primary alcohol gets oxidized to an aldehyde, then to a carboxylic acid, whereas a secondary alcohol gets oxidized to a ketone. So if we go back here and let's look at our secondary alcohol, our propan-2-ol. Now, if we want to oxidize that, what's going to happen is you're going to kick off one of these hydrogens here and another hydrogen from the carbon, and you're going to get your double bonded oxygen creating a ketone. Now, this can't be oxidized anymore. So product C as a ketone would be called propanone. Now, if you're going to oxidize a primary alcohol, you'll get something different. So product D is where you get a carboxylic acid. Now you might ask, how do you know that it's not an aldehyde? The trick is, we've only learned one reaction from an aldehyde. It gets oxidized onto a carboxylic acid. Whereas if you look at product D, you'll see that it goes on to create an ester, another product E, which is completely separate as well, under SOCl2. None of these are aldehydes being oxidized to carboxylic acids. So it must have got oxidized all the way through aldehyde, all the way to end up as a carboxylic acid for product D. And we draw that still with the CH3, CH2, but this final carbon has COOH because it has that double bonded O and the OH group as well. That's a carboxylic acid, and we'll call it propanoic acid. So this is great. We've got products A, B, C, and D. Now let's look at what happens to D going through to product E. And that occurs when we add in a halide, so SOCl2. So let's know if we start with a carboxylic acid, we add in SOCl2, that takes it to an acyl chloride. So therefore, product E must be an acyl chloride. And we do that by replacing this OH from this carboxylic acid with a Cl to make acyl chloride. You'll notice there's still the double bonded O, which is from a carboxylic acid, and we can name this propanoyl chloride, again, because it has 3 carbons, so we keep prop, and the ending for any acyl chloride is anoyl chloride. So this is great. Now we can take this propanoyl chloride and ask what would happen if we mixed it with ammonia. Now we can look at our reaction of when we take an acyl chloride, react it with ammonia, we can see we go to a primary amide. So this is great. Down product F must be a primary amide. And an amide is when the Cl group gets replaced with NH2. So we have the exact same structural formula, but instead of the Cl, we have NH2. And now that this is no longer an acyl chloride, instead it's an amide, we can rename it propanamide. So this is product F. So that's great. Now we can skip all the way back up to product D and see what might get us to ester G and ester H. So let's go through these one by one. So looking at D, our carboxylic acid, if we add alcohol B in the presence of concentrated H2SO4, we're going to go and get an ester. So let's look at what happens when we add an alcohol in the presence of H2SO4 to a carboxylic acid. It goes to an ester, which is perfect. So we know this is esterification. So coming back here, we have our original carboxylic acid, which is our C with the double bonded oxygen that comes from here, from this propanoic acid. And then we get this extra oxygen, which is bonded to alcohol B. And we know alcohol B is a primary alcohol, so it would link up to this first carbon over here and would have another 3 carbons. So carbon, carbon, carbon on this chain. So this would be called propyl propanoate. And you'll need to remember how to name your esters back from level 2. Now there's one other kind of ester we could form. Instead of reacting it with alcohol B, we could react it with alcohol A, which has a slightly different structure. Again, it would be in the presence of concentrated sulfuric acid. So if we look at that, remember, our carboxylic acid is still going to go to an ester, still under the same conditions, but the specifics of where this oxygen connects up is going to be a little bit different because we're dealing with alcohol A here. So it's going to connect up to the CH, which has this OH attached to it here. So this left-hand side from the carboxylic acid is exactly the same. We've got our CH3, CH2 from here, C double bonded O, and then this O here will be connected to this O up here from the propan-2-ol. So it actually connects up then to the middle carbon in this chain because that's the middle carbon that has the OH group attached in a secondary alcohol. So we then have a different name. We've got this methyl group out the top, and then we've got ethyl propanoate. Now you don't need to get this name right to get the excellence marks, but this is how you would fully answer a question using this huge variety of different number of reactions we've learned from organic chemistry to pull it all together in an excellence answer for reaction.
That's the podcast, pussies. I'm out of here.